assumptions for the two-sample t-test, and measuring effect size. Before running a two-sample t-test, we need to check several conditions. First, the validity conditions: good information without bias, a properly selected sample, and no confounding. Second, the sampling conditions: observations must be independent, and the sampling distribution should be approximately normal. The equal variance assumption is critical for the pooled t-test. When both populations have similar spreads, the pooled procedure works well. Notice both curves have the same width, but when variances differ substantially, one group is much more spread out than the other. In this case, the Welch t-test is the safer choice. Now let's talk about effect size. A p-value tells us whether a result is statistically significant, but it doesn't tell us how large the effect is in practical terms. Cohen's d is the most common measure. It divides the difference in means by the pooled standard deviation. The pooled standard deviation combines variability from both groups, so d tells us how many standard deviations apart the two group means are. Cohen provided guidelines for interpreting d. A d of 0.2 is considered a small effect. A d of 0.5 is medium, and a d of 0.8 or larger is a large effect. Here is what a large effect looks like visually. The two distributions are shifted apart by 0.8 standard deviations. You can see substantial separation between the group centers. Finally, let's distinguish statistical from practical significance. Statistical significance means the p-value is below alpha, suggesting the result is unlikely due to chance. But with a large enough sample size, even tiny, meaningless effects can become statistically significant. Practical significance asks whether the effect matters in the real world. Cohen's d is not influenced by sample size. The best practice is to always report both the p-value and an effect size measure. In summary, always check validity and sampling conditions before running a t-test. The Welch procedure is safer when variances may differ. Cohen's d gives you a standardized effect size: small at 0.2, medium at 0.5, large at 0.8. And always report effect size alongside your p-values to tell the full story.